Good morning, friends. Today we are discuss functions. We are taking very elementary questions related to domain of here the use of domain. So how to find the domain? So we know that domains mainly root under f of x. Then here if f of x is greater than equal to 0 or f of x by first quality of finding the domains is first types of finding the domain is root under f of x. So f of x is defined greater than equal to 0 and second is f of x by g of x, then domain is g of x not equal to 0, means f of x here defined either positive number or 0. This is not defined for negative number if x is here real value functions. Similarly, they will ask find the domain when f of x divided by g of x when this is valid, when g of x not equal to 0. And third is log here, log something you consider and f of x. When define this log is defined when f of x is greater than 0. Or for example, I take g of x and g of x also greater than 0 and g of x not equal to 1. And fourth one is 1 by root under f of x. So this is defined f of x is positive. So domain, some certain basic rules about the domain is first is root under f of x. When this function is defined root under f of x, so it is a real value function. This is not a imaginary function. So it is a real value function. So f of x is a either positive or greater than or equal to 0. Means either 0 or more than 0. Similarly, any mathematical tools, they are written in the form of f of x by g of x. Then g of x is not equal to 0. Then we can find the domain g of x is not. Now log is defined. Log f of x to the base g of x is defined if and only if all three conditions, means and f of x is positive and g of x is greater than 0 and g of x not equal to 1, then only this log is defined. Similarly, 1 by root under f of x defined if f of x is greater than 0. So based upon this and some condition, some we can go for greatest integer in equations. There are 4 divisions, we can divide in 4 divisions. Greatest integer is greater than equal to a 1 division, or greatest integer is greater than a second division, or greatest integer x is less than equal to a fourth division, and greatest integer x less than a. So what we do here, greatest integer either greater than or equal to a means greatest integer means x is greater than equal to a. If and only. So greatest integer is greater than equal to a means implies here x is greater than a. Similarly, greatest integer greater than a means we can, for example, greatest integer greater than 2 means we can take greatest integer 3, 4, so on. So what we write here, x is greater than equal to a plus 1. Similarly, greatest integer less than equal to a, then what we consider here, greatest integer less than equal to means less than a plus 1 and greatest integer x is less than a. So there are 4 conditions are there for greatest integer in equations. So use of these questions they requires, in this question they require this 4 inequality of the greatest integers. So first we go for finding the domains. So they are domain here f of x equals to 1 by root under greatest integer x square minus 3 greatest integer x minus 10, and this is the form of 1 by root under f of x means nothing but here f of x is greater than 0. So this part is greater than 0. So greatest integer x square minus 3 greatest integer x minus 10 is greater than 0. Now how to factorize? So to make a simple questions we consider here, consider greatest integer x equals to t. So this is nothing but t square minus 3t minus t 10 is greater than equal to 0. Now we can factorize this. So we can factorize here t square minus 5t plus 2t minus 10 is greater than 0. What is common here? T is the common, t minus 5 and 2 is common, t minus 5 greater than 0. So what we write here, t plus 2 and t minus 5 greater than 0. So t equals to here minus 2 and t equals to 5. But we know what is t here. So we t here consider greatest integer x equals to minus 2. So in the number line, first we write in the number line first minus 2 and 5 plus minus plus. So here t is either less than minus 2 or t is greater than 5. They are telling, we are taking here greater symbol plus symbol here. Because sign of equations here positive, so we are taking positive symbols. So either t is greater than minus 2 or t is lesser than minus 2 or t is greater than 5. So what we do at t is nothing but greatest integer less than minus 2. So just we write here greatest integer, just we write here properties, greatest integer x less than a, nothing but x is less than a. So what we write here, x is less than minus 2. Means what is meaning of this? We can take minus infinity to minus 2 here. Or is here. Now here greatest integer x is greater than 5. Just we write greatest integer x is greater than a. Means what we write here, x is greater than equal to a plus 1. So what we write, x is greater than equal to 5 plus 1 means 6. So both we take, this is telling x belongs to 6 to infinity, and or means union. So what the answer, domain of this function is nothing but minus infinity to minus 2, or means union 6 to infinity. So correct choice here, we consider which one, C options. Now next one more functions. Now we are teaching one more questions. So before going to teach this next questions, we can teach the functional equations. So functional equation, there are mainly 5 forms. So we are going to functional equations. First is f of x plus y equals to f of x plus f of y. Then we consider f of x equals to k into x. K is here constants, arbitrary constant. Second one, f of x plus y equals to f of x into f of y. Then f of x we can consider k power of x, where k is arbitrary constants. Third is f of x into f of y is nothing but f of x plus f of y. Then we can take f of x equals to k into log x to the base a, where k and a is a constants. Next, f of x plus y plus f of x minus y we can write as 2 into f of x into f of y. Then f of x equals to k power of x plus k power of minus x by 2. Either consider this function or consider f of x equals to cos x. And very important, if f of x is a polynomial function, then f of x plus f of 1 by x equals to f of x into f of 1 by x. Then we consider f of x equals to x power of n plus or minus 1. Sorry, 1 plus or minus x power of n. So there are 5 functional, there are 5 elementary functional equations. First is f of x plus y equals to f of x plus f of y. If you come this like this question, we can consider f of x equals to kx, and f of x plus y equals to f of x into f of y. Then we consider f of x equals to k power of x. So similarly we can consider, so we take one JEE Mains questions related to this. So we write here the questions. Question is like this: if function is defined from real to real, its domain is real and codomain is real, satisfy f of x plus f of y, satisfy f of x plus y equals to f of x plus f of y. That's given. For all x, for all x and y belongs to real, and f of 1 is 7, f of 1 is 7, then they asking sum of r equals to 1 to n f of r is, option is given 7n into n plus 1 by 2. Option B is given 7n by 2. Option C is given 7 into n plus 1 by 2. Option D is given 7n plus n plus 1. So these many options are there. So what is given here? They given f of x plus y equals to f of x plus f of y. So here given means already we know this functional equation, they are given like that, f of x plus y equals to f of x plus f of y, this condition, then we consider f of x equals to kx. So now here function we consider f of, now f of 1 is here k into 1 means kx. So f of 1 is given 7, so k equals to 7. So what the function now? F of x equals to 7x. Now we want to find the sum of the series. First you take x equals to 1, so 7. Now x equals to 2, 14, x equals to 21 plus so on 7. Now we consider the given series is clearly they are telling the finding the sum of first n terms of AP, arithmetic progression. So first term is here 7 and common difference is 7. Number of terms is n here. So what is the Sn formula? N by 2 into 2a plus n minus 1 into 2. So n by 2 as it is. 2m is 7 into 2, 14 plus n minus 1 into 7. Now simplify n by 2, 14 plus 7n minus 7, and this is nothing but n by 2, 7n plus 7, and 7 is common, so 7n by 2 n plus 1. So correct option is A. So these types of functional equations that they are asking many times the questions. So according to the situation, these 5 conditions, we can take one condition and we can do. Please, if you like the video, please subscribe.